Good. Start recording. Cool. All right. So I'm Brian Fehrman from Black Oak Information Security. There's my handle on the bottom there if you want to follow me on Twitter. And this presentation I've titled Hardware Hacking the Easyware Way. Pretty much what it is it's designed to give you guys a general overview of how to get into the hardware hacking field. By no means is this meant to make you guys all experts, but it kind of seems like a field that a lot of people want to get into, but aren't quite sure how to. And so, that's what we're going to talk about today. So, not loud enough? Okay, that'll be louder. All right, so let's get started. Who am I? Brian, of course. Married that awesome lady there. Puts up with all my crying and complaining, so thanks to her. Degrees and things, I don't know, lots of them, who cares. What do I do? From day to day, I'm mostly security analyst, researcher, pen tester, trainer. I get to work with those three awesome guys who just spoke before me. I'm really happy about that. To work for John, also amazing. Cat videos, if you guys have any great cat videos, send them to me. I love good cat videos, so send them over. So, why should we care about hardware? Well, one of the things is a lot of people have these same devices, So if I start picking some of these things up, like that, even with just the back of it, you guys recognize what that is? Yeah, a lot of you guys have probably seen that, right? Well, the thing is, a lot of companies also have these exact same devices. A lot of corporations use the exact same devices from company to company. And the thing is that these devices aren't like pieces of software. They're not operating systems. They don't receive updates as frequently. And so a lot of times when these products get put out, you'll find neat little backdoors that get put in for administration, for companies to play around with. So for instance, I got this DOCSIS modem thing here, stuff like that. And so the thing is we just need to know how to look for these little Easter eggs, these little treats. How can we find them? And so again, just before we get going, what do I mean by hardware? Well, I'm talking about a lot of these devices that I have up here. I'm talking about your routers. I'm talking about your modems. Maybe key fobs for your car, which I hopefully still have in my pocket. Yes. Okay, cool. I have not lost these yet. I was actually worried about that. Smart home devices. This is another big one. So we're talking about like Nest. We're talking about security devices, especially things like Vivint. I don't know if you guys have heard of like Vivint, the company. Yeah, those guys come and harass me all the time. So things like that. And additionally, smart grid devices. So now we're looking at houses that are getting these devices put on them so that power companies can remotely control, shut down your high demand energy systems during peak hours of the day. So that's what we're talking about by hardware. And so what good can this do? Well, imagine you're on a test and you're looking at the devices that are available on this company. You find out that they have a publicly facing device that ends up being a router. You find out what type of router this is. So what can you do? Well, go out and buy the same model of router. More than likely, that's going to be available. I mean, a lot of times this isn't some proprietary equipment that only one company owns. It's going to be something that you can go out and you can buy yourself. Go out, grab it, and start playing around with it. And maybe you play around with it, you find out that inside of it, there's this account. It's a root account. And it doesn't get changed by default. So now you might have a way in. How can we actually go about doing this hacking? Well, there are quite a few standard protocols that are built into different devices. And a lot of times when these devices get manufactured, they get put out of the production line, these protocols are actually left open. Some companies do disable them. I'll show you guys when I hold up a couple of these pieces of hardware how they try to do that. But a lot of times these are left open. The thing is, it's not always apparent. If you go back and you look at some older devices, it is a lot more apparent. I was over at a friend's house a couple months ago, and he had like an old box of old equipment like most of us do, and I started picking up and looking through it, and sure enough, on a lot of those devices, it is literally labeled what the protocols are. But that's not always the case. However, we do have some tools that can help us along with this process. So what are some of the protocols that we'll look at here? Well, two of the main protocols are JTAG, so Joint Test Action Group, and also UART, also Universal Asynchronous Receive Transmit, also known to many as a serial type communication. So JTAG, I mean like TV show? No. JAG, I've never actually watched the show, but that's the best pun I could come up with for this. So JTAG, this is a really good one to find. If you can find this and you can interface with this is fantastic. Because a lot of times it's used for debugging and programming the hardware. So as this hardware comes off the line, they can use it for testing the hardware, you can use it for blasting the firmware. You can actually use it for debugging as well, too. So if you can hook into this interface, a lot of times you can run the software that's on this piece of hardware, run the firmware, sorry, and you can step through line by line of what's going on. You can see the values of memory, all that good stuff. And it's what's actually running on the chips on the hardware itself. And in some cases, we can actually use this protocol, this JTAG protocol, to dump off the firmware. So we can grab the firmware from the device itself, we can dump it off, and we can start inspecting it. And so what can we find in this? Well, sometimes we can find things like passwords in clear text. We can find private keys, so SSH keys, encryption keys. You can find all this stuff in there. Maybe some endpoints on the web that with which this device is communicating. And so you can go out, you can play around with those endpoints that you wouldn't have otherwise found, and see what's there. Maybe some backdoors, telnet's open, maybe it's open on a different port than what you would expect. All these things you can go and you can look at. Other things you might be able to do, so maybe you're not necessarily looking to attack some remote device, but maybe you have a device and you want it to do something a little bit differently than what it's supposed to do. Well, if you can get a hold of a JTAG interface, you can actually pull the firmware off, potentially, modify the firmware, and flash it back on. Now you can have it reprogram it, so to speak. What about the UART? Well, this one's pretty awesome to find as well, too. Because a lot of times, if you can find a UART interface, you will get a straight-up console on the device. And a lot of times, this console is not password protected. You drop right into a root shell, and you can start playing around with it and exploring it, which I'll show you guys on one of these devices coming up. Key fobs? Yeah, it's another thing you can play around with hardware hacking. To do this, though, we need to look into what's called software-defined radio, SDR. And I'm going to talk about that at the end of this presentation. I'm not going to go too much into it. I'm going to point you guys to some references, tell you guys how to get started on it, and then you can go out and go nuts. So what are some of the different tools we should get? There's quite a few different things that I suggest. A lot of these devices are actually pretty cheap. I know it seems a little bit intimidating at first, but here's some of the different ones I recommend. Detagulator, starting out. I don't know if anyone's played with these before. So this is by a guy named Joe Grand from Grand Idea Studios. This one's really good, really nice for helping to find the UART and the JTAG interfaces. I think mine might be a little bit defunct. I don't know if it got broken on the way over or what, but we can still use it for at least one of the demos today. What are some of the other things? Whoops. So, going on to the next one. Okay, so some of the other kind of specialty devices besides the JTagulator. So JTagulator, what it's going to do, it's going to allow us to find UART and JTAG interfaces. So we say we find a JTAG interface, what do we do next? Well, a couple different things. We have what's called the bus pirate, which is good for quite a few different things, not just JTAG, but it's just fairly cheap and pretty easy to play around with. It hooks into OpenOCD. Another one, which I haven't actually played around with yet, but I've read good things. The Shikra, another device, fairly inexpensive that you can pick up. This one's supposed to be a little bit more robust than the Bus Pirate. The one issue I found with the Bus Pirate is that they're really easy to brick. I have like 6 of these things now. 3 of them are no longer working for whatever reason. They just stopped. So you just got to be really, really, really careful with these things. Yes, sir.
What's rough cost of each of these?
This will cost you $30. This will cost you $45. This one's the more expensive one, which way I'm hoping it didn't break, but this one will cost you about $175. So I am working on something. I'm not going to give away too many details, but I'm trying to roll these all into something that's going to be a lot lower cost and a lot easier to use, so stay tuned for that. But yep, so that's rough ballpark. What other things should we look at? Well, a lot of little odds and ends here. So one of the big things like a game show host with this. All right. You'll definitely want a soldering iron. I personally like my trusty Weller. They make really, really fancy ones out there. They call like rework stations. You can go out, spend a couple $100 if you want to, get something pretty cool. What I suggest not doing is don't go to Walmart and buy the one for like 20 bucks. That's hardly a soldering gun, in my opinion. It's just a piece of metal that gets really hot. That's about it. But this thing, I think I spent, I don't know, it's under about 100 bucks is what I got from it in store. I'm sure you can buy it on Amazon for substantially cheaper. This one's the WES51. I've had this thing for 7 years now, and I have never had a problem with it. And I put this thing through some serious abuse. It looks old school because it is. It's been around for a while, but if you have something that works, no reason to change it. So highly, highly suggest one of these. What else should you get to go with it? Well, some things just for the soldering station itself. So you'll notice on the bottom of this, it has this little square. So that's meant to be for a damp sponge, so you can clean your tip. That's cool, you can do that. Somebody showed me one of these, though. These things are freaking awesome. You can pick these up on Amazon. I can't remember exactly what it was called, but basically it's just like some metal stuff in there, and you can just stick the soldering iron tip in there, and it just cleans it off, and it's nice. You don't have to deal with the damp sponge. It's fantastic. So, yeah, suggest that. What else do I normally have on my station? So something like this. This can be pretty handy too. So this is called Helping Hands. But you get a little magnifying glass so you can take a closer look at what you're soldering. And also if you need to solder like two wires together, this thing is, you can just stick them in there, you can solder them, it's great. This thing is awesome. I would suggest that. What else? I suggest going out and getting a bunch of these. So these are oh, no. Let's see which way this is going to go. Sweet. All right. So suggest going out and getting these. So, so there's male ends on the wires. That one's male to male, male to female. You can pick up giant packs of these. I suggest just going out, just getting a whole bunch of those. It's really, really helpful. This looks really weird. Slideshow. Alright, what other things? Definitely multimeter. Go out, get yourself one of these. I picked this thing up for like 20 bucks from Walmart. I had another one like it, which I also had at the same time I bought the Weller. It just finally crapped out on me a couple months ago, and I had to go buy a new one. But yeah, 20 bucks. This thing is fantastic. I mean, they make other ones that are good too, but this is really all you need. Basically, the main features you'll need is you just need the voltage feature, the ohms, and then the continuity. So the continuity feature will just tell you basically are two things connected. You get that lovely sound? Go out and get one of these. You'll want one of those. What other odds and ends? Security bits. I don't even know why they call them security bits, because you can just go down to Harbor Freight and you can pick up these things for $5. That's it, and you're in. Hacked. Done. Right? All right. Along with that, some screwdrivers for it. These things I picked up online for about $5. These are pretty handy. You get like a giant set of them. Just these little tweezer things, different shapes, sizes, all that good stuff. $5-10. What kind of solder do I use? Well, I got this one from Radio Shack while it's still around, which tells you how long this will last you if you just go and pick something up. So this one is a 6040 rosin core solder, 0.032 inch diameter. I mean, it doesn't really matter all that much, but I don't know, $6-7, whatever. What else? Sorry, I'll just keep going through my toys here and then we'll move on. So one of these, so this is just kind of a little thing that I think I also got this from Harbor Freight. But basically it's just tiny little screwdrivers, and then you get these little picks and stuff in there as well too. I think this was another $5 or $10. Get yourself a good pair of nippers. That's what I call these, just the little clipper things. And then a good pair of strippers. So, I mean, really, ballpark, For most of these little odds and ends here, I mean, you're talking maybe like $100 or so for all that. $100 on the soldering iron. Sorry, everyone always makes fun of me for how I said that, iron. All right. Oh yeah, and then one of these too, a little breadboard. But definitely want a little breadboard. These are great. Okay. All right. So that's all the stuff. It seems like a lot of stuff, but honestly, if you just go on Amazon and you just search around, you get that absolutely terrible, like you might also be interested in, and so you start out with one thing in your cart, and by the time you're done, you have like 20 things in your cart. I don't know, I just go binging on it. So. All right, moving on. So that's all the stuff, right? So what about for the SDR? Highly suggest the HackRF1. Fantastic SDR device. I don't have it with me, but if you want to do SDR stuff, highly suggest going out and getting one of those, and we'll talk about that a little bit later. Software, what do we use for that? So typically an Ubuntu type OS or Kali is what we're going to use here. Basic serial console, so you can use Screen, you can use Minicom, whatever you prefer. OpenOCD, if you're going to do the JTAG stuff, you'll want to go out and grab OpenOCD, Binwalk, and then GNU Radio. What else? Hacker Kitty. I've always said have your Hacker Kitty. That's her look that says, I stole your chair, what are you going to do about it? Alright. So, let's do a quick live demo here. The fire extinguisher one I'm only half joking about. Video curve.
We're good.
Alright, so got that up. So before we do that, alright. So we're going to look at this little router device that I got. Again, this is just stuff that I just found laying around my house when I started getting interested in this, so I just started going and grabbing all that stuff that my wife told me to get rid of a long time ago. And it's just like, yeah, all right, we got a point of purpose for this now. So I've already got this one soldered in, so let me find. All right, so what are some of the things you're looking for when we're trying to find these interfaces? Something you'll see a lot. All right, can you guys see that? You'll find these quite a bit. So those almost always are going to be for a UART or JTAG type interface. Whether or not they're enabled is a different story, but either way, these are going to be the things you're going to want to look for. It's possible that they might come in slightly different forms. So rather than the holes, you might have something like this, where it's just pads. You got the little pads there. It's either over here as well too. Right, and here again you see the holes. Yeah. So those are going to be the things you're going to want to look for. Something else that's not a bad idea, not too bad of an idea to grab, are these. So these are headers, like that. Sometimes you'll get lucky, the device will have it on them, but most of the time it's not. And so once you find these interfaces, especially if it's like a through-hole type interface, so it's called a through-hole interface, you can go ahead and make things easier and go ahead and just solder on your own headers. Oops, I'm backwards here, right there. So here, I found this interface. If you look real close, so you'll see that I actually have 5 through holes there, but I've only soldered through 3. So if you look really close, which it's really hard to see with this camera, but you'll actually notice that only 3 out of 5 of those appear to be connected. So you look on the board, and oh man, that's really hard to see. But basically, you'll see little lines that go from the holes to other places on the board. Those are called traces. And if you don't see any traces going from the holes, it doesn't necessarily mean there's anything connected. It could be a multi-layer board and you just can't see them. But in this case, this is just a cheap single-layer board. So I knew that only 3 out of these 5 were actually connected. just went ahead and just soldered up some headers to those pins. Headers to those holes. All right. Cool. So next up. Find my wires. Alright, so I know you guys probably can't see this, but that camera is just terrible, I can't do that. So the next thing is I'm just going to grab these wires here, plug them in. Maybe choose ones that I have not jacked up. Okay, so I got it plugged in. And you could plug them directly into the detagulator if you want to. What I like to do is I like to use the breadboard as kind of like a mid interface. Just makes it a little bit less likely that you're going to kind of rip out the stuff from the board, and gives you a little bit more freedom and movement here. Okay, wires here into my headers, wires on the breadboard. Sweet. My wires just fall apart. All right. Cool. So now, the way the breadboards work is that you have what's called the power and the ground rails. So basically, this whole rail is connected. Any one of these holes on the red line is connected together. Any one of these holes on the blue line is connected together. Okay. And then otherwise, it's these rows going by numbers. So going this way. So if I plug these. And like that, these are all connected together. Now I'm going to connect them over to my detagulator. All right. So let's see if we can see this. All right. So in the detagulator, we have these different channels. It's basically 24 different channels we can play around with. And then we also have ground and we have voltage. So I'm going to plug these into channels 0 through 2. All right, cool. So one final thing. Common ground. This is something that will drive you nuts if you don't pay attention to it. Basically, with these electronics, we have what's called a ground reference. So when we're looking at voltage, that voltage is in reference to some other point. In this point, it is ground. We're talking about the ground reference for both of these devices. They need to have a common ground, otherwise this isn't going to work correctly. It's not going to work out quite the way that you would hope that it would. And so how can we get common ground? One of the ways is if you, on these power adapters, the power adapters almost always have this little metal tab on the side. let's keep switching back and forth. Like that. So I've already soldered on the common ground, but you got the little power adapter here, power input on the side of it. There's almost always going to be a metal tab that's almost always going to be ground. Go ahead and solder up a wire to that, solder up a header, solder up whatever you want, it doesn't really matter. But that'll allow you to get a common ground between the J-tabulator and this device here. Okay, cool. So next thing I'm going to do is I'm going to go ahead and I'm going to plug in my router. Hopefully not let out the magic smoke. All right, we have blinky lights. Good sign, right? So I'm going to let that go. And take this camera off, so that's weird. Next thing, I'm going to go ahead and plug in the J-tabulator. It's just a little mini micro, I don't know which one that is, USB connector. All right. And it looks like I'm connected, so that's good. And again, as you can see, you can do this from a VM. You don't have to have a dedicated OS. And now you can use, I don't know, whatever serial protocol you want. Go ahead and use, I don't know, let's use Minicom. So hd/dev/cy USB 0. Let's go ahead and give it a baud rate. For the J-tabulator, it's 115/200. Okay, we're connected. We don't see anything. There's a sweet splash screen, so there's a little reset button on here. You can go ahead and hit it. Hit the reset button. You get the awesome little ASCII art J-tabulator. All right, so once you're in here, we can do something like, first I'm going to hit Control-A-Z. So Control-A-Z will bring up this within Minicom. So there's quite a few different options. The one I'm going to do is turn off local echo, which is capital E. So it's off. So now I can do help, and we can see we have general commands, JTAG commands, UART commands. And so first thing I'm going to do is I'm going to go ahead and type V, so I can set the voltage level. And I'm going to go ahead and do 3.3. Most devices you're going to play around with are probably going to be 3.3 volts. You might run into some 1.8 volts devices, but for the most part, they're probably going to be 3.3 volt. So now I've set it to 3.3 volt. What's the next thing I want to do? Well, let's go ahead and I already know the answer to this one, but let's try to see if there's a JTAG interface. So to test for JTAG interfaces, I've got the I, the B, two options here, ID code and bypass. The ID code is a quick way to determine if there's potentially a JTAG interface on the device. It won't give you all the pinouts, but it'll at least tell you, is there possibly an interface here? It'll be quick, it won't give you all the information, but it'll let you know if you should use the slower option, which is the bypass scan. The bypass scan will go ahead and give you all the pinouts, it just takes a little bit longer. So normally you'll want to run the I command first for the ID code. In this case, I have 3 channels, because remember I hooked up 3 wires. Through and nothing. But if you did find something here, you'd go ahead and you'd hit B, and then you'd be on and checking out to see what the rest of the pins are. All right. Next, we're going to look for UART. So we can see for the UART commands, we have U for identify UART, and then we have P for the UART pass-through. So let's go ahead and let's hit U. And here we can give it a string. I usually just like to do test. Give it the number of channels. 3. Spacebar to begin. It'll start running through this. Nothing. All right. So if you do this and you don't get anything on the UART portion, don't be discouraged. Don't give up. It doesn't necessarily mean there isn't anything there. So watch this. I'm going to reset the device. Now I'm going to run it again. U, test, 3, spacebar. Nothing again. All right.
Did you sacrifice the chicken?
I did not. That might be part of it.
So let's got that, and that.
I know what it is. Hang on. I think that some of those wires that I use. So I highly suggest getting a bunch of these because some of the headers that you might run into will kind of destroy these portions of the connector, and they'll get loose and they won't actually make a good connection. So hang on. Okay, so I've got new wires on there. Let's try again. Give it a second to come back up. All right, so we get the splash screen. I'm going to set voltage 3.3. I'm going to go ahead and load the gun for the UART testing. I'll do testing. I'm going to do 3. And then I'm going to get it to this screen here. Let's go ahead and plug it in. Everyone cross their fingers.
Weights too.
All right, here it goes. All right, so I think that is my detagulator being broken, but have no fear. Just going to try some different channels on there. All right. So I just moved it up from 0, 1, 2, and 3 to be on 4, 5, and 6. So I'm just going to tell it 7 channels. All right. Come on, work.
It's supposed to come up at the end of the song. Yeah. I had to say I wasn't focused enough. You know what it's actually saying.
Literally sweating. All right. So the question was, what is it actually sending? This is one reason so the detagulator is a great device, do not get me wrong, but it does have some downsides, especially when detecting the UART thing. Besides the fact that mine is a little bit broken, even when it's working correctly, all it's doing is it's running through all permutations of the pins that I have selected. So I selected 7 channels. it's going to go through and it's going to pair those up. It's going to say, okay, I'm going to use channel 0 as my send line. I'm going to use channel 1 as my receive line. I chose the string testing, which we can see up there at the top. It will send out that string, and it will look to see if you receive that string back. So it's going to send that testing string over the transmit line, and it's going to look at the receive line and look, okay, did I get anything back? Something that'll probably drive you crazy when you're doing this is on some devices, you might have a UART protocol, but it might just be that, that you aren't able to actually essentially send characters to that at the time that it's booting and receive them back. So you might run this, and a lot of times what you'll likely see is stuff like this. So you see this come back, dot, 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 G, dot, 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 question mark. You'll see a bunch of stuff that is not what you sent. Again, do not get discouraged. That does not mean that you don't have a UART, that you can't interface with it. It just might mean that during the time that you're scanning, you can't necessarily interact with it. So if you see this, be happy. Be very happy, because that means that you can play around with it a little bit more, and you might be able to actually interact with it. It might just take a little bit of work, though. All right, so let's scroll back, now that it's working. All right, let's scroll back.
Question?
Question.
If the remote device does not echo the characters back, then the JTagular fails?
So the question was, if it does not echo the characters back, does the JTagulator fail? Not necessarily. What you'll get is basically what I talked about. So as long as if there's a serial console available, or there's some kind of UART interface, if the device itself is outputting text, as long as you see something coming back, then you might have to go and investigate a little further. It might not necessarily be the word that you sent over, because it might not be echoing, exactly like you said, but as long as you see something, then you might want to dive in a little bit deeper. Good, great question. All right, so scrolling up, I picked this device because I knew that this one does echo back, which makes things a little easier to show, as long as the JTagulator is working correctly, which apparently I'm going to have to get a new one. John? So it goes through, and you see that what it does is we have this TXD, RXD, baud rate, and the data. So this is telling us which of the channels on the JTagulator it used for, it's actually backwards. So this is saying the transmit pin of the device, of the target device, and the receive pin of the target device. So here we use channel 5 for TXD, channel 6 for RXD at a baud rate of 115/200. This one's pretty common. You're usually going to see 115/200 or 9600. Either one of those. There are other baud rates that get used, but you're probably going to see one of those. All right, so now that I've got that, I've got TXD5, RXD6, a baud rate of 115/200. Let's play around with that a little bit more and break more things. Sorry. So now that I've got that, I'm going to use, so hit H again. And for the UART command, you'll see the other one we have there are the P for the UART pass-through. So let's go ahead and do that. Let's do P. And it tells me, enter the new TXD pin, which was 5, the RXD pin, which was 6, and the baud rate, which was 115. Oh no. This is the other thing I don't like, is it doesn't let you delete. That's okay. So I'm going to exit out. Let's try that again. P. So one nice thing though is it saves your previous settings. So here it tells me 5, whereas before it was 0. So I'm just going to hit enter. Enter. This is where I need to change. 115200. And local echo, no. All right, I don't see anything. I can't get anything. Dang, right? No, again, don't be discouraged. Leave this open, like that, and let's reset the device again. Here, really the saying is you try turning it off and back on again, like that really applies to this stuff. Seriously, turn it back off, turn it back on again. What's this? This looks cool.
Is this hacking?
Yes.
It's the right colors.
All right. So typing a bunch of stuff. Hacking at its best. Okay, it stopped. Wait, it's still going. Syntax error. Oh, but it stops. Sweet. Okay. Sometimes you just gotta just type in a bunch of keys. If it doesn't stop, it just spits out a bunch of stuff. Just keep typing in a bunch of keys. Like, it almost always works. It'll crash it. You end up at a drop. Yeah. And so you can do a YouTube video of this of like, here's me hacking. Right? All right. LS. Oh, sweet. What is that? What is that? It's a file system, right? All right. So now you can CD around. I don't know. Up into Etsy. LS. Shadow. No such file directory. I don't know. That one's weird. So root, nothing too big to see there. I mean, we're already root. Here we have like a .pem file, key.pem, cert.pem. So that might be interesting stuff to look at. Of course, this is just your standard router. So I mean, there might be something cool on here, but this is just to give you an idea, right? This is just to give you an idea of playing around with these devices. You might, if you play around enough with it, just using some of the different stuff, you might be able to drop into a shell. Who knows what you're going to find at that point, right? But it's really exciting when you do. I mean, after all that stuff, we're like, oh, is it going to work? Is it going to work? Hey, what is that? Right? All right. So that gives you an idea, though, of using the detagulator and the UART interface. And again, a lot of times you'll drop into a console like this. You'll drop into a console, you won't need a password, and you'll be able to start digging around and seeing what else you could find. Any questions on that so far? Besides, why wasn't it working?
Have you ever gotten a shell on something and added the password file and seen undocumented accounts, like backdoor accounts or anything?
No, not yet, but I do know that they exist.
Question.
Yes.
Can you explain again what was the point of typing all of that stuff? What would happen if we just let it run?
So if we just let it run, what I found with this one is it'll just keep. So sorry. The question was, what was the point of typing all this stuff? And what happens if you just let it run? So if you just let it run on this one, you'll never actually drop into the console. Typing all this stuff, there's at some point in the script what it'll say, hit any key to stop the auto boot process, and that's all I'm doing there. I'm basically just typing stuff until I hit that prompt that kills the auto boot. If you were to let it continue going, it's just going to keep scrolling stuff, and it will never actually drop you into a console. So we're basically just killing the boot process and dropping ourselves into a console. I've seen that on a couple other devices as well. Yes, sir.
And what router was that one that you're doing this test on?
So this was just a Linksys. Let me unplug this. It's also not good to move things around with it plugged in. You will let out the magic smoke. This one is a Cisco. I have a serial number here, but it's basically just a cheap little Cisco router. And I found that a couple of the different Cisco routers I played with, they have the UART interfaces open. So if you want an almost for sure thing that we're going to drop into a UART console, go out and just grab a cheap Cisco router. An old school cheap Cisco router, and you'll probably drop into a console. Good questions. Any other questions before moving on? Alright. Thank you guys for bearing with me through that. That was painful. Alright, so what are some of the other things you can look at? What are some of the other devices I have looked at? It's really sweet. This is something I didn't think about before I started playing around with hardware hacking. Go on eBay and order up a bunch of old, used hardware. So I ordered up one of these, a Cisco AP point. It's used in a lot of different places. I've even seen this in airports. I've seen this in a lot of other places. So I ordered this up. I started playing around with it. I got UART interface on it. I wasn't able to get a full console to where I could play around with it, but just by watching this stuff scroll through, I found quite a few interesting things. I found this had belonged to a hospital. They had sold it off, and they hadn't cleared off their old information from it. So it still had all their certs on it and other information on it as well. And it also had these endpoints. So as I'm sitting there and watching this information scroll by, I see that, oh, there's a status sent out to this endpoint, and we get a response from this endpoint. I go and just pull it up real quick just to see what's there, and sure enough, it's a live endpoint that you can play around with. So you never know what you're going to find if you order it off. The JTAG portion, so The JTAG is actually disabled. It might be hard to see in this picture. But there's the interface to it. You got the lines. Everything looks good until you hop in here. That's solder flux for me playing around with it. But what they did was they actually removed certain resistors and capacitors so that you couldn't interface with the JTAG protocol on this. If you were to solder those back in, you'd be good to go. You could dump off whatever's on there and play around. What else? Here's an example of actually being able to interface with the JTAG protocol. So here I have the detagulator going. This was on a smart meter. Which one? Even though it's separate from the company that we're testing for, the company who made this device said, no, you cannot actually talk about this device itself. So I'm not going to say which one. But it is a smart meter. And we ran the JTAG thing on it, and we found this protocol. So we found out first up here is the quick scan that I was talking about. So that's the ID code scan. So you see that we get out all the pins except for TDI. So it identifies these, but if we want to actually interface with that JTAG protocol, we need all of the pins. So after finding this, I'm like, oh, sweet, okay, there's JTAG protocol. Rerun the bypass, which is a little bit slower, but that'll identify all the pins for you. Then use the bus pirate to actually interface with those, bus pirate and OpenOCD. And after doing that, running OpenOCD with the bus pirate, it has interfaces with it quite nicely. It finds that, okay, there's an STM32 chip on here. With that, we can, once you have that, OpenOCD has a nice command to actually just dump off the image. You can dump off the bin file from it. And from there, you can start playing around with it. So you can do things like run strings against it. And in this case, we found some AT commands and potential communication endpoints, which I've redacted out of there. But still, fun stuff on the device you can go and you can play around with. And the last thing that I want to talk about, so moving on from the JTagulator, any questions on that before I move on? Yes, sir.
What if, I've seen this before, a device is waiting for a certain string? Like, for example, test in all uppercase letters before it will give you anything on the serial port. Is there a way to fuzz it?
Potentially. So if you have to know what it's, what it's looking for, and if not, then you're probably going to have to write up a script to just start sending over strings. Once you've at least found the its receive line, or I'm sorry, its transmit line, and then you can see that interface, and you might have to start playing around with trying to find its receive line, and you could, script up something that just sends over a bunch of strings over different pins. But yep. Another thing I've seen is where some devices they'll sit there and they'll wait for some kind of a network communication or DHCP before they continue. In that case, just plug it into like a router that you have, or something else to send out the DHCP or to get internet access. But yes, good question.
Smart meter, like something that's measuring the gas in your house, that kind of a smart meter?
So smart meter, in this case, it was something used to essentially shut off high demand devices during peak demand times.
Like on my air conditioner or something? Or?
Yes. Yeah. Other questions? Good questions. Just a couple minutes left. So SDR. As I mentioned, you want to get a HackRF1 is the one that I suggest. There's a couple others out there. And these books. Screenshot that. Go out, buy these books. There are 3 of them. They're fantastic. For me, anyways, they definitely took some of the magic out of radio-type transmission stuff. Go out and get these. They're just absolutely fantastic. In addition to the books, there's also an install guide for GNU Radio, which can be a little bit tough to get set up. I mean, it definitely was for me, but go out, check out that link. That'll get you up and going. All right, what else? Other things that'll help you out with your SDR stuff is one of the nice things with the FCC is that they require that basically any of these transmitting and receiving devices register information about themselves. And this information is publicly available and can be quite descriptive. There's a link down there, fccid.io. If you hop on there, you can search around. There's my key fob. And on the back of it, you can't really see it there, but it has an FCC ID. And if you grab that ID and you hop on the site, we can search it, come up with some information, And probably one of the most useful things out of here is this right here, which tells us the exact frequency that this is going to transmit on. So once you've got your hack RF set up, you've got your new radio installed, you're trying to sniff for the traffic, you know exactly what frequency to listen on. Thank you, FCC. And some other information too. I found on this before a manual that actually gave like entire pinouts for devices. It's fantastic, so you never know what you're going to find. So, so that's my talk. Thank you guys for bearing with me for the technical difficulties. Any last questions? Probably just like 1 minute. So. No? All right, cool. Thanks, everyone.